Okay, so let's go through the answer. So number one, definitely just an easy one. Okay, the element is, if you have this symbol, then we know that this is for what element? Nampak tak? If you cannot see, then you can refer to the WhatsApp group. I've shared the copy of this yesterday. So if you have C12.6, C13.6 and C14.6, then we know that this is for element carbon. Okay. And then ini just to refresh back what we discussed yesterday, the number 6 refers to the
Atomic number.
atomic number. Okay. The number 12, 13 and 14 refer to the
Mass number.
mass number. Okay. Alright, so how many protons and neutrons are in the first isotopes? Okay, and we know that jawapan you kena start with proton and then followed by neutrons. And because we are talking about isotope, by right for DEF, number of proton adalah sama, betul? So how many protons?
6.
6. Okay, 6 for all isotopes. So yang berbeza adalah number of neutrons. So this question DEF ni sebenarnya representing the definition of isotope. So untuk carbon 12, how many neutron?
6.
6. Carbon 13?
7.
7. And carbon 14?
8.
8. Okay. Alright. So let's move to number 2. Complete the following. Okay. So we have a table here. Uranium and uranium 235 and 238 basically ada dekat my PowerPoint lecture notes pun. Okay. Tapi kita nak refresh je balik apa yang kita dah discuss malam. So by right, what is the atomic number for uranium 235? Again? Sorry, tak dengar.
92.
92. Okay. And then what is the mass number?
235.
235. So because of the atomic number is 92, then by right we know that number of protons and electrons will be
92.
92. So automatically number of neutrons will be
143.
143. Okay, so ini yang kita belajar semalam lah. So uranium 238. What is the proton number?
92.
92. By right dia mesti similar with uranium 235. Sama kan? So 92. Cuma maknanya number of proton also will be 92. The electrons also will be 92. Cuma bezanya adalah the mass number now will be
238.
238. So automatically number of neutrons will be
147.
and 47. Okay. So now let's move to another pair of isotopes. Kita ada kat bawah tu boron 10 and also boron 11. So what is the atomic number for boron?
5.
5. So the answer will be the same for boron 11, right? Okay. And automatically apa lagi yang sama untuk mereka berdua?
Number of proton and electron.
So electrons. So the mass number for boron 10 will be
10.
10. Boron 11 will be
11.
Typically neutrons berapa?
5.
And also boron 11 will be
6.
breakfast ke belum ni? Lemah je suara.
Belum.
Do you have class before this? Pukul 8?
Yes.
Okay.
Madam,
Yeah.
actually the number of neutron for uranium 238 is 146.
200 and?
38. The number of neutron is actually 146. Not
Ya, kalau
147.
tak ni dia jadi 239 kan?
Yes.
Okay, ni tanda-tanda tak breakfast ni ha. 186. Okay. Alright. So, Yang bawah ni pula dia tak bagi tahu elemen tu apa, but the hint is there. Macam mana kita nak tahu what is the element?
Look at the periodic table.
Ya, okay. Macam mana kita nak tahu which element based on the information yang dia bagi?
Proton.
Kita tengok atomic number dia.
Mass number.
Tengok pada mass number tau. You kena tengok dekat mass number. So it is 33. So which means that this element is
Silicon.
33. Is it silicon?
Arsenic.
Arsenic?
Is it noble gas?
No. Okay, you all tengoklah. Kiranya dia punya mass number will be 33 and its atomic number will be 15. 33 dengan 15. What is that?
Phosphorus.
Yeah, it's phosphorus. Okay, jap. Kita tengok slide. Okay, so what is the symbol of phosphorus?
pH.
P je bukan
P.
pH tau. P.
P.
P. So here. Apa? 33 tadi kan? But because of dia adalah apa nama tu isotopes lah, is isotopes of phosphorus, and then its atomic number is 15, then by right kita tahulah tak lain tak bukan, it must be a phosphorus. Okay, because kita kena tengok as a package lah, atomic number and also dia punya mass number. Okay, so it is one of the isotopes of phosphorus. Okay, so jawapan dia phosphorus 33. Okay, and we know that for protons and electron, by right dia dua-dua adalah berapa?
15.
15.
Okay, and for these isotopes of phosphorus, how many neutron that we have?
18.
18.
18. Okay, so the next one, dia tak bagi mass number, dia tak bagi atomic number, tapi at the same time dia dah bagi number of neutrons and also number of protons. So which means that kita boleh dapatkan mass number, right? Yeah. Okay, so what is your answer? 19 plus 22.
41.
41. So 41 with the proton number 19. So what is that?
Electron also 19.
Okay, 19. Electron memang 19. So daripada maknanya bila kita totalkan kita dapat mass number and the number of proton is representing the atomic number. Maksudnya 19 lah kat sini kan. Okay. So sini 41. Okay. Maknanya this element is
Potassium.
Potassium.
potassium. Okay, so that's correct. Right? Okay, and then any question for this? Clear eh? Okay.
Clear.
Sebab number ni is very important sebab nanti you akan guna banyak kan. So hopefully by doing this kind of exercise you dah tak confuse lagi dah mana atomic number, mana mass number. Okay, so if you look at number 3 ni kita abaikan sahaja nuklear ni. Okay, write the hyphen notation ni sebenarnya dia suruh buat ni lah symbol of element by stating what is the mass number and also what is the atomic number, and you need to identify the element. So agak-agaknya what kind of element with 17 protons, 17 electrons and 20 neutrons. You can refer to the periodic table juga.
Chlorine.
Chlorine.
Yes, that's correct. Chlorine. And what is the mass number here?
37.
37, and dia punya atomic number is
17.
Okay. So soalan nombor 4 tu you all boleh check balik dekat my slide or in the textbook later. That is actually definition lah, definition of isotopes. Okay. You boleh isi sendirilah untuk nombor 4 tu. It's very easy question. Okay, so done for this part. Okay, I have one more. Semalam kan ada share 2. So satu lagi adalah this one ini. Sekejap you can have a look at this first. Okay, so you can see that. Sekejap Okay, ada yang nak tengok Pororo pula. Okay, do you know Pororo? What is Pororo? Okay.
Penguin.
Penguin.
Yes. Okay, so for this question, kita nak kena guna, we need to solve this question by using formula yang kita belajar semalam, the average atomic mass, yang mana the formula is you need to multiply. Sebab don't be confused with the word average. Don't ever confuse with this word sebab average kita kat sini bukan tambah-tambah bahagi dengan 3 atau bahagi 2, tapi we need to consider the percentage abundance. Okay, so what I show here is, you can see for question number 1, kita ada silicon 28 with the percentage abundance of 92.23%. So kita ambil, and then if you look at the atomic mass or isotopic mass lah, dia terms yang sama lah kat situ. Can you see that dia punya decimal places memang panjang lah, dia bagi 27.979 693 AMU, but please bear your mind, you need to take all the numbers, kena ambil semua dalam calculation. Sebab kalau you round off, katalah you ambil 27.98, okay, yang bawah tu pula you ambil 28.98, then your final answer will be slightly different, less accurate lah, less accurate from the real answer. Okay, so you need to consider all, and then if you don't like to include bahagi 100 kat bawah tu, tak apa, tak nak letak bahagi 100, tapi maknanya nilai 92.23% tu kena bahagi siap-siap dengan 100 Okay, so the choices is yours. So in this case, jawapan dia adalah 28.0 something, banyak lah dia punya decimal places kan. Tetapi when it comes to average atomic mass, you can always refer to the predict table, selalunya jawapan dia dalam 2 atau 3 decimal places. So that's why my final answer yang Meda letak kat sini adalah 28.09, and you can look at your predict table, jawapan dia mesti kena sama. Okay, maknanya jawapan kita betul lah. Okay, alright, so itu sampel dia. So nombor 2, 3 sampailah nombor 6 ni, I want you to share your own answer in the WhatsApp group. Okay, bagi-bagilah, mungkin Adam 1 bagi jawab nombor 2, Adam 3, Adam 2 jawab soalan nombor 3, something like that. Okay, so I want to see answers from you. Nanti share lepas kita habis live class later. Okay, and then also your, I don't know whether semalam dah ada ke share dengan madam jawapan untuk 2.50 ada tak yang dah share? If you have done that questions yang daripada workbook daripada textbook semalam, I really hope that you can also share your answer in the WhatsApp group after we finish our live class nanti. Nanti madam akan bagi feedback dekat situ. Okay, so dengan itu kita habislah yang berkaitan dengan isotopes, average atomic mass. Semalam kita juga discuss pasal relative atomic mass and also molar mass. Okay, so for today, let's move to this. Okay, ini. Alright, so what is this? You can also find a very similar diagram in your textbook later. Kalau you buka textbook nanti, dah ada textbook nanti, you can refer to this page number 56. Page 56, kita ada a detailed explanation on what is a mass spectrometer. So ini, tetapi because this is at foundation level, you are going to learn only the basic of this one. Okay, basic sahaja. So, apa itu mass spectrometer? Okay, so this is actually tools of the laboratory. It's a device. Okay, device yang kita guna in the lab, and nama dia tadi again is a mass spectrometer. So apa function? What is the function of mass spectrometer? So this device or tools is used to identify an unknown sample. Maksudnya kalau kita ada satu sampel yang kita tak tahu what is species, what kind of species that we have in our sample. So apa yang kita boleh buat adalah kita boleh guna mass spectrometer to detect. Okay, so first thing that you need to know about mass spectrometer, our sample injected into mass spectrometer must be in gaseous form. Dia mesti in gaseous form. So what we have in figure B2.1 here, our sample is actually neon. Okay, our sample is neon. So when we have this kind of sample, first thing that you should understand is our sample is contain an element. Dia ada satu jenis saja elemen dalam ni. Maknanya kita ada neon. Cuma dalam kes ni kita tak tahu neon ni ada berapa jenis isotop kat dalam sampel kita. How many isotopes that we have in our sample. So to investigate that, okay, kita nak tahu ada berapa isotopes. So what we can do is the gaseous sample of neon will be injected into mass spectrometer. Kita inject dia kat dalam tu. And then inside the mass spectrometer, we are going to have a very high energy, source of high energy beam. Okay, so this source of high energy beams or electrons will collide with the neon atoms. Dia berlanggar dengan neon atoms, okay. And because of we know that originally neon atom ni dia ada berapa elektron, berapa proton, berapa elektron. So we know that because neon is neon 20. So maknanya dia punya proton 10, dia punya neutron 10 and of course dia punya elektron also 10. Okay, and bila kita inject into mass spectrometer, apa berlaku tadi? The source of energy will collide with neon atom. Apa yang berlaku kat sini adalah electron will be knocked out. Okay, dikeluarkan daripada neon. So kalau the electron is knocked out or being removed out from the neon, what do you think? What happened to the neon atom sekarang?
Hilang satu elektron.
Selepas dia hilang satu elektron tu, dia jadi apa?
Kation.
Ambil.
Yes,
And
dia jadi positive ion. So ini benda yang paling penting yang you all kena faham. Our sample now become positive ion. Okay, so nampak kat sini lah, it's something like asalnya 10 elektron, sekarang dia ada 9 elektron, so that it will becomes neon plus. Nampak? Sebab dia positive ion kan? So daripada asalnya yang kita inject tadi neutral, sekarang our sample becomes positive ions. Yang ni memang again and again kena ingat when it comes to mass spectrometer. Okay, so apa berlaku dekat this positive ion? Okay, so this is the detail of what happened in the mass spectrometer, but don't worry, you don't have to memorize the process, tak perlu. Cuma madam just nak explain saja apa yang berlaku, tapi what happened inside the mass spectrometer tak penting. It's just an additional information for you. So daripada tadi kita tahu dia berlaku kat sini with the high beam of energy, the electron is knocked out, and then now you have positive ions. So this positive ion will be accelerated. Okay, dia akan dipecutkan, accelerated to the next stage. Yang mana the next stage, you can see kat sini, the positive ions will be deflected. Okay, will be deflected. Yang mana dia punya deflection ni adalah based on mass of positive ion. Okay, dia akan dipecahkan mengikut berat. Okay, mengikut berat, yang mana the analogy is mungkin yang the lightest particle will be on the left, the heaviest particle will be on the right. So dia akan deflect lah, deflect. Okay, and then at the final stage dekat hujung ni, the positive ion will be detected. Okay, will be detected. Macam mana dia detect? Sama juga dia akan detect based on the mass. So dalam kes ni kalau kita punya elemen tadi tidak bertukar jadi positive ions, then mass spectrometer tak boleh detect. So that's why it's very crucial for the element to be converted to positive ion in the first process. Dia kena tukar tu jadi positive ion, lepas tu deflected and detected. Okay, so tugas korang untuk this part adalah sebenarnya to learn on how to interpret a graph printed from the mass spectrometer. Nanti at the end of the process pada siap semua, kita akan print satu graph yang mana this graph is called mass spectrum nama dia. Okay, we call it as mass spectrum. So by right, starting from now, bila madam sebut mass spectrum, then you all patutnya it is understood that we are talking about graph. Okay, so graph rupa bentuk dia yang sebenarnya dalam bentuk macam ni lah. Maknanya kalau kita guna komputer, so it will be displayed like this. Okay, and then when you print out, dia akan print out dalam bentuk macam ni. Tapi because you are at foundation level, you just need to interpret a very simple mass spectrum only. So biasanya you all akan dapat mass spectrum dalam bentuk macam ni. Yang ni yang ada highlight sekarang. Okay, you akan dapat yang macam ni. Okay, so what I want to explain to you adalah kita tengok pada ni dulu. Boleh nampak kan? Can you see? Okay. So in terms of interpretation, mula-mula kita tengok dekat y-axis and also x-axis. Okay, so for the y-axis, you can see the label is percentage abundance. So y-axis is telling us how many percent of that isotopes available in our sample. Daripada situ kita boleh tahu yang ni ada 20%, yang ni ada 50%. And we know that when we are talking about percentage abundant, just like what we discussed yesterday, is always scale to 100%. Okay, so ada percentage kan, so mesti kita akan scale to 100%. And then on the x-axis pula, okay, so this x-axis is representing the mass. Nampak? Dia tulis kat situ mass. And remember, we are dealing with isotopes. So bila isotopes, semalam kita dah discuss the unit of isotope from our calculation of average atomic mass, the unit is always AMU. So it is advisable setiap kali soalan suruh sketch, y-axis ni you letak siap-siap unit dia. AMU. Letak kat ujung tu. Okay, mass, and can you see ada slash charge kat situ? Okay, so the reason why we have mass per charge kat sini, because remember our sample now have been converted to positive ion. Sebab tu dia punya level of charge, level of mass is mass per charge, ataupun short form dia kalau mass spectrometer ni you always see this symbol M/E. So M/ ni maksudnya mass per charge. Okay, so this is always will be your x-axis. Okay, so selesai faham untuk y-axis and also x-axis. Okay, so now look at the peaks. Madam, the AMU is for y-axis or x-axis? That is for x-axis sebab y percentage abundance, x adalah mass, so A adalah for x-axis Okay, so let's look at the peaks pula. Can you see how many peaks
3.
available on our mass spectrum? Ada 3 kan? Okay, and you can see yeah, that's correct, there are 3 peaks and all of the peaks have a different intensity. Okay, so mula-mula apa yang you all kena faham adalah number of peaks. This is especially when we have a sample that contain element like this. Macam contohnya kalau sampel kita neon, sampel kita helium, sampel kita apa lagi, argon gas ke, so it is dalam bentuk elemental form, then the number of peaks is always representing number of isotopes. Okay, number of peaks is telling us the number of isotopes that we have in our sample. Maknanya dalam case ni kita tahu kita ada 3 peaks, which means that our neon sample is consist of 3 isotope. Ada 3 isotope. Yang mana the intensity of peak ataupun tinggi rendah peak tu is telling us the abundancy okay, tak muat. Okay, it's telling us the abundancy, maknanya yang paling tinggi itu adalah the most abundant species, yang paling pendek itu adalah yang the least abundance. Okay, so maknanya dalam case ni, because now we already know that there are 3 isotope, then macam mana kita nak identify the isotope, then we need to refer to the mass. So sebab kita ada peak pertama tu dekat berapa AMU?
20.
Look at x-axis. Yes.
20.
Peak pertama kita berada dekat 20 AMU. Peak kedua kita
21.
21.
22.
21 AMU. Yeah. At peak number 3 is at
22.
22.
22. Okay, so you can see you have different masses. yes, of course, isotope akan ada different mass. Okay, so which means that yang pertama dekat peaks at 20 AMU tu adalah for neon 20, right? Neon 20. Sebab mass dia adalah 20 AMU. And then bear in mind, because now we are dealing with species from mass spectrometer, then dia kena ada plus sign. So maknanya dekat 20 tu, dekat 20 AMU, that is for isotope neon 20 plus. Okay. And then for peaks at 21, maksudnya sekarang our isotope is for okay, so again, our sample is neon. Okay, inject dalam mass spectrometer, neon akan bertukar jadi positive ion, and at the end of the process, mass spectrum keluar ada 3 peaks. So yang daripada peaks tu kita nampak ada 3 berat yang berbeza. Satu 20 AMU, satu 21 AMU, satu lagi 22 AMU. And we already identify that dekat 20 AMU tu, that is species responsible for the peaks is neon 20 plus. Okay. Neon 20 plus. So maknanya peaks at 21 adalah untuk neon berapa?
Neon
21.
21.
21 plus.
Neon
21 plus.
21 and compulsory untuk letak plus sign dekat hujung tu. Sebab it's from mass spectrometer. And last but not least, at 22 AMU, definitely kita tahu dia adalah neon
22 neon
22
plus.
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 Okay, and soalan boleh tanya, what is the most abundant isotopes in the sample? Dan jawapan dia adalah neon 20
20 plus.
Kena ada plus. Okay, so is that clear?
Yes.
Don't worry, kita ada banyak lagi exercise that I'm going to discuss with you. Okay, yang ni if you go through my slide, the next slide will be this one, tapi ini adalah repetitive saja yang menggunakan formula average atomic mass. So solution is already provided, so you boleh tengok je jawapan dia. Okay, nanti tengok je sendiri right, and then this is a predictable. And this one also another additional practice on the average atomic mass pun sama. Kita dah discuss pun semalam. So let's go straight away to this practice. Okay. So this is one of the possible question that can be asked about mass spectrometer ataupun mass spectrum. Don't be confused. Mass spectrometer is a device. Mass spectrum is a graph. Okay. So given that in this question, the mass spectrum of an element is shown below. With the aid of predictable, identify the element. Kalau tadi kita dah tahu dah sampel kita neon. Okay. Tapi in this case, dia bagi tahu element. So kita kena carilah what is this element. So based on our interpretation on the mass spectrum given, so of course kita tahu y-axis is percentage abundance, mass per charge kat sini unit dia AMU, dan kita tahu it's representing the mass. So if I ask you, our element here ada berapa isotopes?
5.
5.
How do we know? Macam mana kita tahu?
Because there are 5 round.
There are 5 masses. Peaks.
Ada 5 peak kan? Kita nampak kita ada 5 peaks kat situ. Maknanya ada 5 isotopes. Itu antara benda pertama. Bila kita tengok sampel kita element, number of peaks is representing number of isotopes. Okay. And then dekat what kind of mass yang kita ada ni? Okay, look at the scale. So mass of isotope pertama kita jumpa dekat mana tu? Berapa AMU?
70.
70 AMU. And then kita ada juga dekat
72.
AMU.
okay. Lepas tu
74.
okay, number 4.
AMU.
And last but not least,
76 AMU.
okay, so yang mana paling banyak? Most abundance?
74.
Isotopes with a mass of 74. So kat sini you all boleh tulis lah. This is 22.6%. This is 26.4%. 36.6. This is 7.4 and last but not least it is 7.0. Okay, so persoalan dia macam mana kita nak identify the element?
Mass.
Kita kena kira apa in order to identify the element based on data yang kita extract ni.
Average.
Average mass
atomic
number.
mass.
Yes, that's correct. Kita kena kira average atomic mass by using formula percentage abundance darab dengan isotopic mass. So I'm giving you a few minutes untuk kira and then lepas tu kita identify what is the element. Kira dulu.
Please turn off your mic.
Tak apa, it's showing that Adam nak share jawapan dia sekejap lagi. Nyanyi lagi sekali, Adam mana tadi? Tak sempat nak tengok.
Ada Sabli.
Adam Sabli.
Sekejap lagi tanya jawapan.
73.6.6.
Yud.
Ada Arif nak bagi jawapan ni.
Tujuh puluh empat ya.
Berapa? Okay, when we are talking about average atomic mass, normally dia akan ada decimal places lah. Kalau boleh, you must write down your answer to 2 decimal places for the average atomic mass.
Madam, I want to ask a question.
Okay, yes.
AMU tu, dia stands untuk apa? Ke just a unit?
Atomic mass unit. Ingat tak semalam? You
Okay.
kena ingat atom molecule kan dia special, dia tak boleh guna kilogram dan semua kan. So kita ada atomic mass unit. So short form dia AMU.
Okay, terima kasih madam.
Mute. Madam,
Yes.
is it the answer is 72.342?
72.3 34
342. Yeah.
Okay, how about the rest? You got the same answer?
Same.
0.6.
No. I got
I got
7.634. I got
answer.
7. Yes, I got the same as Arif. Yes.
Which
So,
I get 0.6. Madam, 72.634.
If I'm not mistaken, jawapan dia 72.6 tau.
Yes.
Data tu terbalik.
Yeah.
Data tu balik.
73 dengan 74.
Okay, so for those yang dapat 72.34, cuba kira balik, okay, because by right the answer is 72.6, okay. Kalau tak dapat juga nanti kita minta siapa-siapa yang dapat 72.6 boleh share jawapan dekat WhatsApp group,
Madam,
Yes.
I think because they calculate from the data that you wrote. Sebab terbalik 73.66 tu.
Oh,
Mungkin because of
okay.
that.
Ni itulah saja test kurang ni apa nama prihatin ke tak ni yang ni. Saja je nak test. Okay, so jawapan dia sebenarnya 72.6. Okay, alright, so let's identify pula. Kita identify. Kita tengok dekat predictable ni, agak-agaknya what is this?
Germanium.
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 Germanium. Ini. Okay, so inilah tuan dia, GE. Okay, so the answer is GE. Okay, so yeah, the answer is GE. So is that clear, class?
Yes, madam.
Yes, madam.
Yeah.
Okay, let's see more example on the mass spectrum. Sebab mass spectrum ni quite popular. Memang soalan popular lah untuk topic 1. Okay, so what we have now is okay, let's read the question. Dia kata our sample is HBr molecule. Okay, so ini first kelainan kita. Because in our previous example, we are using neon. Yang tadi GE kan. So semuanya dalam bentuk elements. But in our third example here, what we have is molecule ataupun it can be also compound ke kan. So bila dia HBr molecule, so you need to bear in your mind, HBr molecule is consists of hydrogen bonded, chemically bonded to bromine. So there is a chemical bond there, okay? And dia bagi tahu pula our sample ni ada isotope of hydrogen 1 and also hydrogen 2. And at the same time untuk bromine pula kita ada dua jenis isotope, bromine 79 and also bromine 81. Okay, so what I want to explain first, sebab you nampak ayat kat sini hujung ni dia kata assume fragmentation does not occur. So I would like to explain about fragmentation. So for information, when our sample of HBr is injected into mass spectrometer, so dia punya proses masih sama lagi macam elemen tadi, yang mana there will be a high beam of energy that will collide to the molecule of HBr, dia belanggar. So apa akan terjadi adalah the electron will be knocked out. Okay, elektron keluar. Okay, bila elektron keluar, kita tahu something different here tadi. Kalau tadi dia tak ada chemical bond, tapi dalam kes ni dia ada chemical bond. So dalam chemical bond ni, what do you think? When the electron is knocked out or removed out, what do you think? What happened to the chemical bond? Chemical bond is weakened ataupun become stronger. You bayangkan HBr molecule ni masuk dalam mass spectrometer, belanggar-belanggar, lepas tu elektron dikeluarkan. So what happened to the bond? Becomes weakened, becomes weaker or stronger?
Weaker.
Yes. Definitely weaker lah. Dia akan jadi lebih lemah. Ikatan dia lebih lemah sebab dia dah kekurangan elektron. Elektron has been knocked out from the bonds. Cuma dia punya situation yang pertama adalah the bonds is only weakened. Dia cuma dilemahkan sahaja, tetapi molecule of HBr remain intact as a molecule. Maknanya lepas electron is being knocked out, HBr ni cuma bertukar jadi HBr plus. Okay, tetapi maknanya molekul ni akan remain intact as HBr. There is no bond breakage. So dalam kes ni kita kata sebagai no fragmentation take place. Okay, sebab tiada ikatan yang putus. Ikatan cuma dilemahkan sahaja. So that is our first situation when we have molecule as our sample. Situation yang kedua, okay, sama juga, we inject our sample, HBr belanggar-belanggar, elektron keluar, and in this process ada some of the HBr molecule breaks the bonds. Bond breakage, ada berlaku bond breakage. So bila bond breakage berlaku, dalam kes ni some of the molecule will remain intact as HBr, tetapi ada sesetengahnya bila dia putus ni dia akan jadi apa? You just imagine, some of the HBr molecule putus dia punya ikatan. So dia akan produce apa daripada pemutusan tu?
Gas hidrogen dengan bromine.
Dia akan, you tengok kat sini, because we know that our sample mesti akan bertukar jadi positive molecules. Okay, and then suddenly they collide lagi sebab we are talking about high energy kan, dia berlanggar lagi, keep on berlanggar, yang mana ada setengah molekul tu putus dia punya ikatan. So bila putus, makanya dia akan hasilkan H plus ion and also Br plus ion. Sebab dia putus ikatan dia. Tapi kalau kita ikutkan, Br ni selalunya negative ion kan, but because we are talking about mass spectrometer, it's always a positive ion because it will involve removal of electrons. So bila ikatan HBr putus, dia akan hasilkan fragments like H plus dan juga Br plus. So in this second condition or situation, kita kata sebagai fragmentation does occur. Berlaku fragmentation. So boleh faham tak dua situation for molecule? Okay. So again, if you have a sample, you want to ask a question?
Yes.
Yes, I
So fragmentation happen when they collide too many times.
Yes. Maknanya the intensity of the collision is very high, causing that molecule, the bond within molecule will be broken out. So dalam case ni kita kata ada berlaku fragmentation. Okay. So maknanya you should understand when our sample is a molecule, dia akan ada dua situation. No fragmentation and ada fragmentation. Okay. Macam mana kita nak tahu ada fragmentation ataupun tak ada? Soalan memang akan bagi tahu. Macam contohnya in this question, assume fragmentation does not occur. Maksudnya tak ada yang akan berlaku bond breakage. And if based on your understanding, what do you think? Which one you should see more peaks? The one that undergoes fragmentation or the one that does not undergo fragmentation? Mana satu yang kita akan nampak lebih banyak peaks agak-agaknya?
The one that happen fragmentation.
Yes, okay, that's very important too for you to understand. Okay, sebab apa? Kenapa bila kita ada fragmentation you will see more peaks? Because bear in your mind, bukan semua yang akan pecah. Ada yang remain intact as a molecule, tapi some of the molecule pecah. So bila pecah dia hasilkan H plus dan juga Br plus ion. Maknanya more species can be detected by mass spectrometer. So of course dia akan keluarkan lebih banyak peaks sebab dia akan ada mass yang berbeza-beza. Betul? Okay, tak apa. Let's do this. Okay, kita buat soalan ni. Okay, mula-mula kita stick to this question. Dia kata HBr molecule ada all those isotopes and assume fragmentation does not occur. So let's solve this. Okay. Okay, so because of we know that our sample is HBr. Oh, jap. Nak buat bond dia. HBr. So our possibility of combination, masa kita inject sample kita tu, our sample can be a combination of, maknanya dalam sample kita ni adalah a mixture of HBr molecule yang diperbuat daripada hydrogen 1 and also bromine 79 because again kalau you all tengok soalan ni dia kata hydrogen ada dua isotop, hydrogen 1 dan juga hydrogen 2. Lepas tu bromine ada dua isotop, bromine 79 and bromine 81. Okay. So maknanya molekul kita tu yang ada dalam sampel kita tu boleh jadi a combination of hydrogen 1 dan juga 79, bromine 79. Boleh faham ni? Okay. So bila dalam mass spectrometer dia undergoes all the process, maknanya nanti at the end of the process mass spectrometer kita detect dia sebagai hydrogen 1 bromine 79 plus. Maknanya dalam case ni tak ada fragmentation lah sebab bond dia tak putus. Okay, so if we have this species detected by mass spectrometer, what should be the total mass dia? Mass dia berapa kat sini?
80.
Yes. 80 AMU. Nanti akan ada satu peaks lah dekat 80 sebab mass spectrometer detect species ni. Okay, lepas tu ada possible species selain daripada hydrogen 1 bromine 79, dia mungkin boleh juga combination of hydrogen 1 dengan bromine 81. Kan? Okay, bila masuk dalam mass spectrometer, of course dia akan jadi positive ion. This positive belongs to the whole molecule lah. Kiranya molekul ni dah bertukar jadi positif. Okay, so dalam kes ni kalau molekul kita ni adalah combination of hydrogen 1 and bromine 81, maknanya the mass detected will be
82.
82 AMU. Okay, that's correct. Okay, tell me, what is our third possibility?
2
Hydrogen 1.
bromine 79.
Hydrogen
Hydrogen 2.
Hydrogen
2,
2.
Hydrogen 2.
Bromine
Dengan
79.
Bromine
79.
79.
79. Don't forget the plus sign.
Plus
Okay, and what is the total mass kat sini?
81.
81.
81.
AMU.
81 AMU.
Pula.
Is there any other possibility combination?
Another one.
Dia
Apa?
Hydrogen
281 bromine.
2 bromine
Bromine 81.
2.
plus. So total mass dia berapa?
83.
83 AMU. Okay, so kita dah tahu dah. It's possible kalau tak ada fragmentation, these are all species that can be detected by the mass spectrometer. So disebabkan kalau kita tengok balik soalan kata write the formula of the species that will appear in the mass spectrum. Kita dah buat dah tadi. Soalan B dia kata sketch a label mass spectrum of HBr molecule. So kita nak sketch kita punya mass spectrum. So we are going to start with y-axis. We are going to label this as percentage abundance. Kan? Okay. And then x-axis kita adalah mass per charge. Okay. Mass per charge kena label dulu. Mass per charge. Lepas tu baru letak dalam bracket AMU. Okay. So now kita nak buat scale dia. Disebabkan oleh mass yang kita jumpa tadi. Mass kita kan kita ada 80, ada 82, 81 dan juga 83. So we are going to draw the scale now. Okay, kita nak lukis scale dia. So kita kena make sure scale kita kena ikut susunan. Must be in sequence, in order. So you kena start with the lightest first. Okay, lightest kita tadi 80. Okay, followed by 81. Lepas tu apa tadi? 82 and also 83. Okay, so which means that you must have 4 peaks in your mass spectrum. Okay, now sekarang kita nak lukis dia punya peaks dah. Okay, cuma my question is, how about the intensity of peaks? Mana peaks lebih tinggi? Mana peaks lebih rendah? So kita tengok balik information yang soalan bagi. Okay, so dalam ni soalan bagi percentage abundance for individual isotope. Dia bagi percentage abundance untuk hydrogen 1, hydrogen 2, bromine 79 and bromine 81. Is there any percentage abundance given to the molecule?
No.
Tak ada kan?
No.
So kalau you all dapat soalan macam ni, sebenarnya kita tak penalize on the intensity sebab there is no information given. So soalan yang macam ni biasanya kita nak tengok whether your species are correct or not. So maknanya kat sini you boleh je simply lukis je ini tinggi sikit. Okay, mana-mana lah. Mana-mana. Sebab kita memang tak bagi markah on the intensity of peak. Dengan syarat kat sini kena cukup 4 peaks and you have to label. Kat mana kita nak label dia punya species, common practice is biasanya kita label on top of the peaks. So dalam kes ni 80 tadi adalah for hydrogen 1 Br79 plus. You akan dapat satu markah for the first peak. So all together kat sini Meda rasa selalunya kalau soalan macam ni dalam 4 to 5 marks. Banyak tu 4 hingga 5 markah. So you have to make sure that you must label correctly. So lepas tu 81 berapa? 81 hydrogen 2 bromine berapa dah? Bromine 79. Plus sign ni sebenarnya for your information common mistakes done by the students. Ramai sangat student yang akan lupa nak label positif. Sayanglah sebab species dah betul. Peaks pun dah betul tapi you tak letak positive sign, biasanya caranya kita akan penalize once. Kalau maknanya semua species tu you tak letak positive sign, kalau ikutkan markah you dah dapat full marks kan, tapi you will be deducted 1 mark sebab tak ada positive sign. Rugi juga. Okay. So 82 tadi berapa? Hydrogen 1 Br81 plus. Lepas tu last one is apa tadi? 83. Where is 83? Hydrogen 2 Br81 plus. Okay.
Madam.
Yes.
Kalau macam mana kalau dia minta percentage abundance sekali?
Okay, kat sini biasanya if there is no information given in the question, don't worry about the intensity. Dia memang takkan tanya dan memang tak akan ada markah on the intensity. Because for your information, sebenarnya yes, dia ada cara dia untuk kira maknanya daripada individual peaks tadi, dia ada formula dia sebenarnya untuk kita kira macam mana tinggi rendah untuk molecules. But that is for higher level. At your level, if there is no information given on the molecule, kita abaikan sahaja dia punya intensity of peak. Okay, boleh?
Okey, faham.
Madam,
Yes.
H tu memang tak ada charge ke?
Okay, this charge yang plus kat hujung tu is actually not belongs to bromine tau. Tapi dia belongs to the whole molecule.
Oh, okay.
Okay? Alright. So ini kita faham this is our answer when there is no fragmentation. No fragmentation. Following the question lah tadi. Dia kata no fragmentation. Tapi sekarang I want to show you a different scenario kalau soalan kata assume there is the fragmentation does occur. Maksudnya ada fragmentation. So I think I'm going to use yes, Hakim, did you raise your hand?
Madam, kalau kita masuk spektrum ni, dua-dua akan jadi positif kan?
Yes.
So, bila dia buat hubungan ikatan tu, dia covalent ke ionic ke? Dia punya ikatan tu.
Okay, so dia originally dia memang kalau ikutkan dia memang covalent. So it will remain as covalent walaupun dia form charge. Okay?
Okay.
Alright, so now kita pergi ke second possibility. Second scenario kalau soalan kata fragmentation does occur. So kat sini I'm using blue color for fragmentation. Okay, sebab as you said just now, tadi Meda dah tanya, kalau soalan tu adalah ada fragmentation and we are going to see more peaks yang lebih banyak kan. So kenapa kita boleh nampak peaks yang lebih banyak? So kita tahu when you have fragmentation, by right all of these species memang akan ada. Sebab bukan semua molekul yang akan pecah. Dia akan ada juga molekul yang remain intact. So meaning that if you have fragmentation, 4 peaks ni mesti tetap ada. Tetap akan ada. Cuma on top of that, bila kita ada fragmentation, some of these molecule akan putus. Okay? So bila putus, contohnya hydrogen 1 Br79+. Kalau dia putus, dia akan jadi apa? Hydrogen
1 plus.
Yes, dia akan jadi hydrogen 1+. Okay? And at the same time, the other one, dia akan jadi apa? Bromine 79 plus. Okay. Yang ni pula putus. Dia akan jadi hydrogen
1 plus.
Okay. So hydrogen 1 tadi kita dah detect dah. Hydrogen 1, what is the mass?
1.
So 1 AMU. Yes. Okay. And then bromine 79, what is the mass?
79.
79 AMU. Okay. Lepas tu molekul kedua tadi putus. Hydrogen 1 tu berat dia sama je dengan hydrogen 1 plus tadi mula-mula kan. So dia akan appear on the same peak. Okay. Dia akan appear on the same peak. So kita abaikan dia. Tapi the other fragment adalah?
Bromine 81.
Yes. Bromine 81 plus. Yang mana berat dia berapa kat sini?
81 AMU.
81 AMU. Okay. Lepas tu kita tengok fragment yang ni. Kalau dia putus, dia akan hasilkan, of course ada bromine 81 plus. Yang mana berat dia sama je lah, 81 AMU. But the other fragment yang putus tu, apa?
Hydrogen 2 plus.
Hydrogen 2 plus. So if there is a fragmentation, in total berapa peaks yang kita boleh nampak? 8. Yes, that's correct. That's why if we have fragmentation, you will observe more peaks sebab kita akan ada individual peaks. Okay. So sekarang bila soalan suruh sketch, kejap nak. Okay. So kalau kita nak lukis dia punya mass spectrum, okay, Meda nak panjangkan sikit dia punya scale. Okay. So sama juga, the y-axis is the percentage abundance, but in this case we are going to have more peaks dekat depan ni. Kita ada dekat 1, kita ada dekat 2 dan juga kita ada dekat 79. Okay, alright, so now in terms of intensity of peaks, sebab sekarang dia adalah individual kan, individual isotope. So kalau you tengok balik dekat soalan, kan dia ada bagi kat sini, kalau hydrogen 1, dia punya percentage abundance adalah paling tinggi, 97.99. So untuk case macam ni, you will be penalized on the intensity of peaks sebab dia bagi information dalam table ni. Okay, maknanya at least you kena tunjukkan peaks yang paling tinggi dalam case ni adalah hydrogen. Kita kena guna logik lah sikit kat sini. So you are going to label this as hydrogen 1 plus, and then when you want to sketch for hydrogen 2, sebab you nampak percentage abundance dia sikit je, 0.012, maknanya dia kena jauh lebih rendah lah kat sini. Okay, jauh lebih rendah berbanding dengan hydrogen 1. So label hydrogen 2 plus. Boleh? Okay, and then for the bromine 79, kita nampak kat sini dia punya intensity is 50, almost the same like bromine 81 lah, dia 50-49 lebih kurang lah sebab nama pun sketch we actually not drawing an accurate mass spectrum pun, it just a sketch. So kat sini you akan letak lah bromine lebih kurang lah, lebih kurang, this is bromine 79 plus. And our fourth peak will be at berapa?
81.
Okay, 81. So ada setengah orang, dia 81 ni nampak tak? Kita dah ada peaks for at 81 yang mana it is H2Br79 plus kan? So both species, kedua-dua species ni H2Br79 plus dengan bromine 81 are sharing the same peak sebab dia ada mass yang sama. Okay. Alright, tapi sebenarnya in a real mass spectrum, you will see ada splitting sebenarnya. So that's why I would prefer you all, walaupun dia sebenarnya pada mass yang sama, Madam prefer kalau you all lukis je lagi satu lagi peaks untuk 81. Lukis je peaks untuk 81. Okay, sebab dalam real mass spectrum pun sebenarnya kita boleh nampak lah peaks dia split sebenarnya. So on this one, you are going to label this as bromine 81 plus. Okay, tapi ada setengah orang dia label je kat sini, dekat peaks yang sama yang hitam ni, dia label je kat sini N, bromine 81 plus. Okay, ada. Tapi I really prefer kalau you just draw another peaks, tapi you label with the same mass, 81 AMU. Tapi daripada situ understood lah, they are sharing the same mass. Okay, boleh? Okay, so as I said, this is a very popular questions, memang akan keluar dalam quiz. So memang you kena buat banyak exercise, but unfortunately dalam kita punya textbook kita ni, dia not really focus on the mass spectrum. Dia lebih banyak fokus kepada calculation of average atomic mass sahaja. Sebab tu when you scroll down memang dia tak ada pun exercise untuk mass spectrum. Okay. Tapi don't worry because workbook yang Madam akan share hari ni akan ada a few more exercise or questions on the mass spectrum. You all boleh cuba yang tu, dan on top of that I have more question here. Okay. So ini because I'm going to end my live class. Okay. So after this kita still ada remaining time kan for chemistry. So apa you all boleh buat adalah you can screenshot this question. Okay, screenshot dulu yang ni. Okay, and then also done Okay, and one more ini. Okay, ini you can screenshot this. Tapi dia ada AB yang ni A give the mass per charge values for all the CO plus peak 1. Lepas tu B dia adalah sketch the mass spectrum of the CO gas sample. So untuk exercise yang Madam bagi ni, semuanya adalah molekul. Semuanya molekul. Soalan pertama tadi HCl, soalan kedua adalah CO. Okay. So by right, the way you answer this question sama macam our discussion tadi, you need to know whether ada fragmentation or not, and I believe soalan 1 dengan 2 ni dua-dua no fragmentation. Okay, so maknanya lebih senang lah, maksudnya kita tahu molekul kita semua remain as a molecules. Okay, boleh dikatakan pun Meda kata the common trend adalah soalan suka tanya yang no fragmentation, tapi tidaklah bermaksud tak boleh tanya yang ada fragmentation tu. Okay, boleh?
Madam, I have a question.
Yes?
Fragmentation tu, macam mana nak tahu dia jadi ke tak jadi ke dia ikut soalan?
Soalan yang bagi. Okay? Memang
okay.
soalan akan bagi tahu. Macam contoh, dia mesti akan ada ayat kat ujung tu. Assume there are no fragmentation. Assume fragmentation does occur. Macam tu. Dia mesti ada keluarkan statement tu. Okay?
Alright.
And you will see this statement kalau sampel kita molekul tau. Sebab kalau sampel kita elemen, dia tak ada isu ada fragmentation ataupun tidak. Sebab kalau sampel kita elemen, basically kita nak tahu how many isotopes saja. Okay? 5 peak, 5 isotope. Macam tu je. As simple as that.
Madam.
Yes, kau.
Tengok balik soalan B tadi.
Apa?
Soalan B.
Ni. Okay. Alright. So, any question before we end our session?
No, madam.
No, madam.
No. Okay, Alhamdulillah. So, hopefully you boleh try buat. Kalau ada apa-apa nanti kita discuss